Welcome to SanfordFlipMath Student Edition. This is Michaela.
Joy, Cecilia,
Santo.
Jacobia. Here are some definitions you need to know. Asymptotes are the line that the graph approaches but never touches. Vertical asymptote comes from the x value that makes the denominator equal 0, but not the whole. Horizontal asymptote comes from the leading coefficients of the highest exponent in the numerator and the denominator. Whole or wholes, x values that are not included in the graph, comes from the factors that are canceled out in factored form.
Vertical asymptote, the first equation of the denominator that is equal to 0. So you will take your x plus 2 instead of equal to 0. Then you subtract the 2 on both sides, and then you will get x equals negative 2. So your vertical asymptote is x equals negative 2.
Your horizontal asymptote comes from the leading coefficients of the highest exponent in the numerator. So in this problem, your highest exponent is x squared. So 3x squared divided by x squared equals 3. So for this problem, your horizontal asymptote is y equals 3. As you can see, we divided this 3 by x squared, which takes that away, and you're left with 3. For the next part in solving this function, we're going to work on the wholes. The wholes are the x values that are not included in the graph, and they come from the factors that are canceled out in factored form. In order to cancel out a factor, there has to be the same factor in the numerator and the denominator, and we see that here with the x minus 2. So we would set our factor x minus 2 equal to 0. We will add 2 to both sides. Then for our whole, we would get x equals 0. 2. Now, continuing on with trying to solve our function, we are going to solve for the x-intercept. And to start off with solving, I'm going to go to a clean page. And then it will be easiest to find our x-intercept if we use the factored form of the equation, which is right here. As Mr. Sanford often says, when we have x-intercept, the y is always 0. So the first thing we're going to do is set the y equal to 0. And we're going to rewrite our function over here. The first thing that jumps out to me when I look at this equation is that there is an x minus 2 in the numerator and an x minus 2 in the denominator. So these two factors can cancel out. So when we rewrite our equation, it will be 3x plus 9 over x plus 2 equals 0. And we don't like fractions, so the first thing we need to try to do is cancel our denominators. And to do that, we will multiply both sides by x plus 2. Anything times 0 is 0. And then we'll multiply this side by x plus 2. And that will cancel out the denominator. And what we're left with is 3x minus plus 9 equals 0. I need more room, so I'm going to scroll this down. Okay, that was a lot. So what we're going to do is subtract 9 on both sides. We end up with 3 x equals negative 9. We divide by 3 on both sides. We end up with x equals negative 3 as our x-intercept, which will be written like this.
We are now entering the graphing segment of our video. As you can see, our equation is already put into the calculator, and here's how it looks when we hit graph.
So right now on the graphs, we're going to represent our vertical asymptote, our horizontal asymptote, our hole, and our x-intercept. So right now, our vertical asymptote again intercepts at x equals negative 2, which is right here. So we'll draw a little dotted line. And then our horizontal asymptote is at y equals 3. So I'm going to draw a dotted line right there. And we can't have a graph without a hole. And our hole again is 2. So I'm just going to circle that right here. And our x-intercept is negative 3. As you can see, it intercepts right here. And that's it for our graph. All right, guys, thanks for watching our Sanford Flip Math Student Edition. Again, this is Joy.
Sanso.
Cecilia.
Michaela, Jacoby, see you guys later.